Hi everyone, we are CI1 group. Today we will finish our page presentation. Here is our team member. Let's start with the project benefits. This project can help us save time for instructors, like using the automatic tools to reduce the manual review work. And it also can handle large classes easily, like using the visualized interface skills to a lot of students. And it also can boast the transparency and consistency. And it also will be very helpful for clear fast student learning progress by using the visual comparison help teachers understand how student logic evolves. And it also can support better feedback by compare the code different repos, make it easy to give targeted feedback. And as for the project objective, it is make it more faster and more efficient for the code review. And it's reduce the manual workload for instructors. And it also can better insight into student progress, like providing meaningful learning analysis. And this last one is it can ensure the transparency of student submission and support consistent feedback with visualized data. And as for the project implementation, the first one is the structured data collection. It automatically greater submission records from the platform. And the version tracking and validation compares different variants to highlight meaningful code changes. And as for the interface dashboard, the parent submission history in an intuitive and visual format. Um, and it also can ensure all submissions are recorded and reviewable. So that's all the parts of the project introduction. Next, we will go through for the project feature.
Hello, everyone. Let me now introduce some of the key aspects of Gradescope. Gradescope can handle different types of submissions, including code, text files, and templates. This makes it quickly to analyze assignments and give fast feedback on how students are doing. This feature greatly simplifies the assignment grading process. However, Gradescope has some limitations. For example, it only allows us downloads of the last submission. It's hard for us to really dig into how a student's code has changed over time. Also, the platform doesn't have interactive charts, so we cannot see any changes in code, test results, and score trends in a dynamic vision way. To overcome these challenges, we propose a few enhancements. Firstly, we suggest allowing instructors to access all submission histories or selected specific versions for download, which would offer a more comprehensive view of each student's learning process. Secondly, implementing AST Analyze would automatically detect changes in code and present them in an organized format. This would help instructors understand students' code improvements and refining their teaching strategies. Lastly, we plan to introduce interactive charts to visually illustrate the progression of code and grading trends. This vision would help teachers quickly identify where students have having trouble, allowing them to give more focused advice and feedback.
There are three main features of the program that I would like to introduce. Firstly, this program transforms the way instructors evaluate student code, moving beyond simple pass-fail assessment to provide a comprehensive understanding of the development process. It uses code evolution analysis abstract syntax space to reveal the complex pathway of code modification. This deep structural analysis allows instructors to trace the precise evolution of code, recurring errors, and identify areas of improvement. By understanding the patterns, instructors can provide targeted feedback, helping students refine their coding skill more effectively. Secondly, this analysis is enhanced by dynamic visualization of changes and metrics. These visualizations translate complex data into easily simple formats, showcasing code modification, performance metrics, and statistical trends with clarity and precision. Instructors can effortlessly identify patterns, spot outliers, and gain a complete view of student progress. And lastly, for courses with multiple assignments and large student groups, scale analysis across multiple assignments features enable instructors to compare student performance across a series of tasks, identify trends in learning across the curriculum, and easy to evaluate large datasets. This feature ensures consistency in grading and provide valuable insights into overall course effectiveness. And the next part is the project structure.
In this part, I would like to introduce how our project is built. The entire system is constructed using a three-layer architecture arranged in a triangular structure as you can see in the picture. Through these three layers, we progressively process complex data and ultimately deliver a clear and intuitive result to the user step by step. First is the data pipeline layer. After obtaining a valid login cookie, we automatically fetch all student submission information and code from Quickscope using its API. We store this data either on the local file system or in a database in the form of JSON files and compressed code archives. For example, if a student makes 5 different submissions for the same assignment, we save each submission student's information and Quickscope submission timestamp in JSON format, along with the corresponding code file. Second, is the analysis engine layer. The backend system reads these code files from the database or local storage and uses an abstract syntax tree called AST to identify structural change in the code. For instance, if a student adds a new function or modified a block of logic in the second submission, we can accurately detect these differences. We transform the raw JSON file JSON data into a well-structured and cleaned and analysis-friendly format that seamlessly supports further data analysis and visualization. This includes data validation, cleaning, and aggregation to compute metrics. We then expose this processed data to APIs for front-end to use. Moreover, we can even leverage AI to identify common issues in students' assignments. The last level is the visualization interface layer for customer. We present the analysis results to instructor to teaching assistants. For example, instructors can view a line chart to see how test score change with the number of submissions, or a bar chart to compare the scale of code modification between submission and so on. In this way, the entire system forms a complete workflow and make it much easier for teachers to assess and compare student assignment performance code quality.
Our project runs from week 2 to week 14. By week 4, we had outlined our project phases and began meeting regularly with our supervisor to align on goals. In week 5, we will finalize our tools, like Beautiful Soup for scrapping and Click Simulation tool for dynamic web pages. By week 6, we will define roles, finalize requirements, and identify key challenges. Weeks 7 and 8 are building for our first working prototype. In weeks 9 and 10, we will test the system with simulated Grayscope data, trying out both individual and full-class submission scenarios. Week 11 is for polish features and refining the interface. By week 12, development should be complete. And in weeks 13 and 14, we will deliver our final presentation, report, and all the project materials. To wrap up, our system tackles code submission challenges in large classes with 3 main features. First, efficient data handling, automating data collection and storage in JSON files and SQL databases. Second, performance analysis, using AST-based comparison and time series graphs to track student progress. And third, a user-friendly dashboard, built in React.js with interactive charts and side-by-side code reviews. Together, these features make grading faster, feedback clearer, and teaching more effective.